Hi students, this is Mr. Yang. In this lesson, we are going to learn something called average rate of change. The lesson is kind of easy but also a bit confusing. Easy because it's related to a concept that you have learned extensively last year. A bit more complicated is because we're using some new notations and things are going to look a bit different. So, prior knowledge. Slope. Slope represents how steep a line is and is also called the rate of change. And you can already see, well, rate of change is actually part of the title because they are related. But let's quickly review how to calculate slopes with 2 points given using the slope formula. M equals y2 minus y1 over x2 minus x1. Here, we are given two pairs of points, and you are going to use them to find the slope of the line between them. If you're always confused with how to actually use the formula, well, then label the points, because the points typically are ordered pairs as x comma y. Since we have two pairs of points, we're going to separate them by using a subscript 1 or 2. So the first point is going to be x1, y1. The second point is going to be x2, y2. As soon as you label them, now we just need to put everything into the formula. On top of the formula is y2 minus y1. y2 is 3, y1 is 5, so it's 3 minus 5. On the bottom is x2 minus x1, x2 is 2, x1 is 1, so it's 2 minus 1. Top is going to be negative 2, bottom is going to be 2, so it simplifies to be m equals negative 2. You can pause here and try it with b and c, but be careful with the negative signs. Now you can come back and check. Let's label them x1, y1, x2, y2. M equals y2 minus y1 is negative 4 minus 7. x2 minus x1 is 2 minus, this is where you gotta be careful. Minus is already in the calculation, but the number itself is a negative 3, so it's gonna be subtracting a negative 3. You need both the negative sign, and they will become positive. The top is a negative 11, the bottom is a positive 5, and you can't simplify that fraction. C, x1, y1, x2, y2. M equals y2 minus y1 is negative 4 subtracting a negative 1. The number itself is negative 1 and we're subtracting it, so you need both negative signs. Become positive. Then it's negative 2 minus 6 on the bottom. The top is negative 4 plus 1, which becomes a negative 3. The bottom, negative 2 minus 6 is a negative 8. Simplifies to be 3 over 8. That's a quick review on how to calculate slopes from two given points. Now let's talk about average rate of change. We're going to involve a new concept called a secant line. You're going to learn more about that next year when you learn about circles. But for now, secant line is a line that intersects a curve in at least two places. Let me draw a quick demonstration. Let's say you have this exponential graph. Well, here's a line that's going to cut through. This line is called a secant line because it cut through with 2 points, and definition is at least 2 points. Here, this is not a secant line because it doesn't look like it's going to intersect at all. This is not a secant line because it only intersects with 1 point. Even this is not a secant line because it's just touching at 1 point, so it's still not 2 points. So next year, you're going to learn about circles, where you will have a lot of different secant lines, and they will all have some kind of properties that you will learn more about. Now, let me erase all these. Let's talk about average rate of change. Slope exists when we work with straight lines, but this year we have just learned about exponential graphs, and they're not straight lines at all. When we work with these graphs, we are going to need to refer to them as average rate of change, because we can't call them slope anymore since they're not straight line. Rate of change is also just a different name for slope. So here we're going to call it average rate of change. The formula is f of x2 minus f of x1 over x2 minus x1. When you write the slope formula on the side, y2 minus y1 over x2 minus x1, as you may notice, the bottom are exactly the same. As for the top, well, it is technically y2 and y1, but since we're talking about functions, and we are talking about the relationship between x and y, that's why we replace the y2 and into f of x2, replace the y1 into f of x1. And sometimes we may actually need to calculate them instead of just identifying them from points. And also, since when we calculate slopes, we need to write m equals. Here, we still need to write average rate of change equals, but that's a bit too long. So in short, we're going to write it as AROC. A-R-O-C. So you have noticed that the formulas are very similar. So finding the average rate of change is basically finding the slope of the secant line between the 2 points on the graph. So let's start with graphs. Example 1. Find the AROC on 0 to 2. This is something that you have just learned in the last unit. It's interval notation. We are using square brackets because we're including the endpoints. So here's what it actually means. These two, the interval actually gives you both of the x values. So it means you're finding the AROC from x1, which is 0, to x2, which is 2. So now, let's see how we can find it. In the last unit, when we learned about key features, we have learned to identify different values on the graph. So x1, well, let me write the formula on the top. F of x2 minus f of x1 over x2 minus x1. x2 and x1 are given in the interval. So now it's time to identify f of x1 and f of x2. If x1 is 0, that means you're trying to identify what is f of 0. If x2 is 2, you're trying to identify what is f of 2. So let me remind you what you have learned in the last unit. F of 0 means when x is 0, what is the function value? So x equals 0 is right here. You're going to drop that down. You're going to look for all the x equals 0s and find a point on the graph, which is exactly right there. And the function value right there is at -3. So f of 0 equals -3. F of 2, that means you're looking for x equals 2 and see what the function value is, and the function value is a 0. Now we can calculate the AROC. F of x2, which is f of 2, 0. Subtracting, so it's basically the second pair subtracting the first pair. So it's 0 minus -3 on the top, and the bottom is a 2 minus 0. So the top becomes 0 plus 3, which is just a 3, and the bottom is just a 2. So AROC is 3/2. You can pause here and try it with example 2. Now let's have a look. The interval that is given to you is -3 to 3 with square brackets, which means x1 is going to be -3 and x2 is going to be 3. And then you are finding the f values of them, or in other words, the function values. So you're going to find f of -3 and f of 3. F of -3, so when that's -1, -2, -3. When x equals -3, the function value is at 11. And same thing with f of 3, 1, 2, this is 3. The function value is at 11 as well. Let's find the AROC. 11 minus 11, the second pair subtracting the first pair, the bottom is 3 minus -3, which is 0 over 6, which is 0. Now let's go back to look at the reason why I mentioned about secant line. Here's the secant line that goes through these 2 points. In other words, you're finding the slope of that secant line, which is the average rate of change between the 2 points. You see it's rise of 3, going up by 3, and then going to the right by 2, so the slope is 3 over 2. And here, for the second graph, the secant line is right here, and that's a flat line, horizontal line, which does have a slope of 0. So you see, the secant line, you're basically finding the slope of the secant line when you're trying to find the average rate of change. The reason we don't always do that is because, well, in these 2 examples, you are given the graph. You're not always going to be given the graphs. But here's the idea. Let's move on to tables. Example 3. So the interval tells you your x1 is -1 and your x2 is 2. So it's time to identify the function values, which is f of -1 and f of 2. F of -1 is 6. F of 2 is 48. AROC. The second pair subtracting the first pair, so it's 48 minus 6 on the top and 2 minus -1 on the bottom. 42 over 3, which is 14. That's example 3. Example 4. Same thing. The interval tells you x1 is -3 and x2 is 1, and you're trying to identify f of negative 3 and f of 1. F of negative 3 is at negative 2. F of 1 is at 7/4. Now we can calculate the AROC, which is 7/4 minus negative 2, and then it's negative 1 minus negative 3. So the top is going to, oh, sorry, not negative 1. This is just a 1. Okay. So the bottom 1 plus 3 is a 4. The top 7/4 plus 2 is going to be 15/4. And if you type in your calculator, this is where, it's a good habit when you type in fractions, type into parentheses. So it's 15 divided by 4, then divided by 4 again. That's going to be 15/16. That's example 4. Moving on, now, for the first 4 examples, you're just identifying the function values. Now, we're going to need to calculate the function values. So example 5. The same idea, x1 is given as negative 2, x2 is given as 1. And you need to calculate f of negative 2 and f of 1 based on the functions. This is also something you have learned in the previous unit, which is a very important skill for the rest of the high school, which is plug in. So we're plugging in negative 2 to replace the x. 3 to the negative 2 power minus 4. And that is going to be, let's see. The next one is 3 to the first power minus 4, which is 3 minus 4, and that is just a negative 1. As for the previous one, this is a 1/9. Subtracting 4 is a negative 35/9. Calculating the AROC. Second pair, subtracting the first pair, so it's negative 1 minus negative 35/9. On the bottom is a 1 minus negative 2. The bottom is going to be a 3, and the top is going to become a positive. So negative 1 plus 35/9, that is 26/9, so simplifies to be 26/27. That's example 5. Example 6, same idea. Let's plug numbers in. But first, x1 is negative 2, and x2 is 5. Now you're just calculating f of negative 2. So it's 2 times negative 2 squared plus 1. And the next one is f of 5, which is 2 times 5 squared plus 1. Some of you would make the mistake here that you multiply the 2 and the negative 2 together and then square. However, you need to square first, because even though PEMDAS says parentheses first, but there's no calculation inside this parentheses, just a number negative 2. So you're still doing exponents before multiplication. So negative 2 squared is a 4, times 2 is an 8, plus 1 is a 9, and then 5 squared is a 25, times 2 is a 50, plus 1 is a 51. So AROC is going to be 51 minus 9/5 minus negative 2. That's a 42 on the top and a 7 on the bottom, simplifies to be a 6. Now you can pause here and try example 7 and example 8, since they're very similar to example 5 and 6. Now let's have a look. Example 7, x1 equals negative 3 and x2 equals negative 1. Let's plug them in. F of negative 3 is 3 times 2 to the negative 3 power plus 5. And the second one is f of negative 1, that is 3 times 2 to the negative 1 power plus 5. So the second one is going to be, that's a 3 times a 1/2, so 3 halves plus 5 is a 13/2. As for f of negative 3, that's going to be 3/8 plus 5. So it's going to be 43/8. Let's calculate the AROC. Second pair, subtracting the first pair, 13/2 minus 43/8 over negative 1 minus negative 3. So the bottom is just going to be a 2 because of negative 1 plus 3. As for the top, it's going to be a 9/8. The whole thing simplifies to be 9/16. Lastly, example 8. x1 is negative 4, so you're calculating negative 3 times negative 4 squared minus 4 times negative 4 plus 7. x2 is negative 1, so that is going to be negative 3 times negative 1 squared minus 4 times negative 1 plus 7. The first one after calculation, that's negative 3 times 16, so it's negative 48. That is a plus 16. So it becomes a negative 32 plus 7 is a negative 25. Next, negative 3, this is a plus 4, so it's a 1 plus 7, it's an 8. So let's calculate them. A rock equals 8 minus a negative 25. On the bottom is a negative 1 minus a negative 4. So the top becomes a 33, the bottom becomes a positive 3, which means the A rock is 11. And that's example 8, and that is everything for this lesson. Thank you.